This is Dr. Amudapriya, Associate Professor Triply of Rohini College of Engineering and Technology, Palkulam. We are discussing about the subjects protection and switchgear for the electrical students, and the lecture deals with the apparatus protection of feeders. So apparatus protection, it is a vital part of any power system because the consumer's apparatus is the key parameter which is on which the total operation of any power system is depending on. Even if the usage of a consumer alters, if they increase their consumption, obviously the generators will supply extra amount of electricity. If the consumers are reducing their consumption, obviously the generation has to be reduced. So the entire part of the power system is relying over the apparatus. So hence the protection of apparatus is a vital one. Here we can have many different types. So the first one is application of directional relays to parallel feeders. It may be seen from the figure which is given below the given below that the relays placed at the load side of both the lines use a directional element which respond to a direction away from bus bars. Similarly, the relays placed at the source side do not require any directional element. A similar concept of discrimination is also utilized in the ring main feeder, a feeder which is fed by both the ends. It can be observed that the relays placed near the bus connecting the sources do not have any directional features, while the rest others will be having direction based one. It's a good practice to locate a fault at any place where among different sections of the feeders and check whether the particular section only is isolated without disrupting the power flow in other sections. Next is the pilot wire schemes for feeder protection. In differential protection scheme, the current entering at one end of the line and the other one which is leaving at the other end is compared. The pilot wires are used to connect the relays. Under normal working condition, the two currents at both ends are equal and the pilot wires do not carry any current. But under a fault condition, the two currents at the both the ends are no longer the same. This causes circulating currents to flow through the pilot wires and makes the relay to trip. So when considering the merged price voltage balanced system, this is a three-phase system in which RYB are connected through the pilot wires. This is the thing. They do have their advantages and limitations, and this can be made a better one by the translay relay. So the translay relay is another differential relay. You can see the primary winding is being connected from the CT current transformer, and later on we can connect the upper electromagnets, the middle leg, to the lower magnet, and this part is being connected to the trip circuit. Here we do have an aluminium disc which is connected to the spindle, and that is being connected to the center arm or middle arm of the upper E-shaped electromagnet. Here many relays may operate because of unbalance in the current transformers. The copper rings also adjusted that the torque due to the current induced in the copper ring due to primary winding of relay is restraining and do not allow the disc to rotate. It is adjusted just to neutralize the effect of unbalance existing between the CTs. The copper rings also neutralize the effect of pilot capacitive currents. Though the feeder current is same at two ends, a capacitive current may flow in the pilots. This current leads to secondary voltage by 90 degrees. The copper rings are adjusted so that no torque is exerted on the disc due to such a capacitive pilot currents. Therefore, in this scheme, the demerits of the pilot relaying scheme is somewhat taken care of. There are many advantages, including it is of optimal cost. Next is the carrier current unit protection. So let us see about the carrier current unit. Upon seeing this unit itself, it will be a better beneficial one. Different DC components of the same are being discussed. The coupling capacitors, which offer low reactance to the higher frequency carrier signal and higher reactance to the power frequency signal. Therefore, it filters out the power frequency or low frequency and allows a high frequency carrier waves to the carrier current equipments. A low inductance is connected to CU of the coupling capacitor to form a resonance circuit. Here the second picture describes the Z value which is equal to 1 by omega C1, and that is the values given. Next is the wave traps. Wave traps are inserted between the connections, so we can have that in between the bus bar and the connection of the CU. These traps are LNC elements, normally the LC filters, which are connected in parallel, and they are tuned in such a manner that they offer low reactance to the power frequency signals and high reactance to the carrier waves. They ensure that neither of these different frequency signals gets mixed up before being received at the bus bar. Before both the CU and the wave traps are protected from switching and lighting surges with the help of suitably designed spark gaps or paristors. Frequencies facing different frequencies are used in adjacent lines, and the wave traps ensure that the carrier signals of other lines do not enter a particular line section. Hence, the proper choice of frequency bands of different lines are being adopted. While considering the transmitter unit, the carrier frequency is in the range of 50 to 500 kilohertz of constant magnitude is general in the oscillator, which is fed to an amplifier. Amplification is needed in order to overcome any loss in the coupling equipments, weather conditions, deep meshes, etc. And the amplifier and oscillators are constantly energized, and connections is made between the two with the help of control unit. So we can see all these things here. And the receiver unit consists of an attenuator and a bandpass filter, which restricts the acceptance of any unwanted signals. The unit also has matching transformer to match the line impedance and that of the receiver unit. Thank you. These are all about the electromagnetic relays.